So in this question, we have to compare the covalent character of SnCl2 and SnCl4. Now student, in SnCl2, we can write it as Sn2 positive plus 2 Cl negative. Whereas for SnCl4, we can write Sn4 positive plus 4 Cl negative. Now in both the compounds, we are finding that the anionic part is common, that is the chloride. But here in SnCl2, the charge on Sn is 2 positive, whereas the charge on Sn in SnCl4 is 4 positive. Now we have discussed already that when the charge on cation increases, then in that case the covalent character increases. So we can conclude that when the cationic charge increases, we find that the extent of polarization also increases and the covalent character increases. So from this we can conclude that SnCl2 will be less covalent than SnCl4 because the charge on Sn is 2 positive, which is smaller than the charge on Sn, which is 4 positive in SnCl4. So the conclusion is, here we have to compare the ionic character of sodium fluoride, sodium chloride, sodium bromide and sodium iodide. In the very first question, we found that the anion in all the 4 compounds were common, but the cations were different, and by comparing the size of cation, we had discussed the covalent character. Now here we have got sodium fluoride, second is sodium chloride, third is sodium bromide and fourth is sodium iodide. Now in each of the 4 compounds, we are finding that the cationic part in all the 4 is common, but here the anions are different. In the first we have got fluorine, in NaCl we have got Cl, in NaBr we have got bromine, and in NaI we have got iodine. Now it should be remembered that through the Fajan's rule, whenever we have to observe the ionic or the covalent character, we are just dependent on 2 factors. One is the size of the cation or anion, and other is the charge on cation or anion. Now here, since in all the 4 cases cations are common, so we have to compare the size of the anion. So with the increasing size of anion, the extent of polarization increases, the ionic character decreases and the covalent character increases. Now if we compare the size of fluorine, chlorine, bromine, iodine, then what we find that all these 4 elements, that is fluorine, chlorine, bromine and iodine, they belong to group 17 of the periodic table. Now what we know that in any group, when we move down, there is increase in the atomic radius. So if we compare the size, we find the size of iodine will be maximum, then bromine, then chlorine and then fluorine. Now previously we have discussed that as the size of anion increases, there will be increase in the extent of polarization and hence the ionic character will be decreased. Means due to the largest size of iodine, NaI will have the maximum ionic character. After iodine, we have got NaBr, whose ionic character will be greater than that of NaI because iodine being the largest in size will possess the maximum covalent character. Now smaller to bromine we have got chlorine, so the ionic character of NaCl will be greater than NaBr, but its covalent character will be smaller than NaBr, and the most ionic will be sodium fluoride, which will have the least covalent character but the maximum ionic character. So once we compare the size, we find that the iodine has got the maximum size as it is at the bottom of the group 17. Smaller to it we have the bromine, chlorine will be more smaller than bromine and fluorine will be the least. Now as we have already studied that as the size of the anion increases, there will be decrease in the ionic character and increase of the covalent character. So ionic being the largest among these 4 elements, we can conclude that sodium iodide will have the least ionic character and the maximum covalent character, whereas fluorine being the smallest will have least extent of polarization and hence NF will be the most ionic and the least covalent.